Hi everyone, today we are going to look at hash table. The reason why hash table is developed because we need a better algorithm to store our text and search for it. So example, if you have a lot of text, right? Example, if you want to look for a single value, say AAAB, right? You need to compare if like we got 1000 lists of text, right? You need to go through each text. Like we want to find first A. If it's not A, then we need to go to this list A, then only we found it. Then only we stop the loop. This is a traditional linear search. But if this A is like in the most bottom of our text, actually there's one solution also. We can do a sorting first, then we can do a binary search. The second thing what we can do is we can use this called as hash table. What hash table is essentially doing is it's going to sum up each of these characters and give one value. Example, right? If we got 1000 lists, right? So let's say we make a 1000 array, and each array, right, would have each of the index. For example, if we get the ASC2 value, right? ASC2 value of the individual character, and we sum it up, and then we can directly call the position. Like example, if we sum up this position, right? For example, if it's the index is 0, right? Just example, okay? Just example. If this index is 0, right? You can directly go to this location. Then this location will be A. But we have one problem. The first problem is, how do we make sure each of these characters it would result in 0? So the answer is we use modulus. The first solution to this problem is use a modulus. Let's not use 1000, okay? Let's not use 1000. 1000 is a bit big. So let's say we have an array size of 7, okay? So let's say 1, 2, 3, 4, 5, 6, 7, okay? 7. So the index is 0, 1, 2, 3, 4, 5, 6, okay? Index is 0 to 6. How do we make sure our add up item would always result in between 0 to 6? So the answer is using modulus. For example, if our table length is 7, right? So we are going to modulus with 7, okay? We are going to modulus with 7. The second question is, example, if we have a text of like, let's say cat, okay? We have a text of cat. Then we have second text called as TAC, tag. Okay, if we only sum up the individual of the character value, right, of the ASC2 character, then CAT will be equivalent to TAC. Because if you look at the ASC2 table, right, for example, right, the small character A is 97, okay? This ASC2 table, you don't need to manually code this, you can directly call char add, okay? Char add. And also, right, by default, if you are using Java, right, the character can be converted to integer. When it's integer, right, it will return the what you call the ASC2 value. Okay, so small letter A is 97, Z is 122. Let's look at C. C is 99, 97, 116. So it's 99, 97, 116. If you only add up this item, right, it will be say N, right? So if we add up this 116, 97, 99, if we add up this item, right, it will also be N. So N will be N. So if N is equal to N, right, we cannot get a unique position. We cannot get a unique position to fill in this array. This is what is called as collation. Okay, collation. So what we can do is we can use certain algorithm. There are a few algorithm available. Like I am just picking out one of the algorithm. Under different key, right? Under different key, it's better to use a better different algorithm. And when you are doing with hash table, right, prime number is the key. Prime number, okay? Prime number is like a magic number. So if you want to set your array size, right, it's better you set using prime number, okay? The reason behind it, I didn't go and fully study it, but it's always advisable you use prime number. So you need to have a sub-module to write a prime number. So example, right, if user say you want to set the array size as 4, right, so you want to automatically set the array as 5. 5 is a prime number, okay? So if like the user, also there's one thing is you need to back out one number. So it's like this. You want to minimum collation. How do we minimize it? So this is one of the algorithms. This 33 is written by Bernstein. How he get 33? I'm not sure. So if you are interested, you can go and Google up Bernstein. Okay, Bernstein. You can go and Google up his name if you want to know how he get this 33. So if you want to have a hash number that is almost unique, right? So use the individual character multiplied by 33. Hash index first. Use the hash index multiplied by 33 and add up the character value. So example C, right, is 99. So in the first character, right, 99 plus 0. And then for T, right, which is 166 plus 0, okay? And then in the second row, right, the second character is 97. So initially the hash ID, right, the hash ID will be 99. For this one, initially it's 99, okay? Then for this one is 116. 116. So use 33 multiply with the hash ID. So use 33 multiply with 99, then use 33 multiply with 116, and then add up with the next character value again. So this is how he able to generate a kinda almost good enough hash. Okay, so when you modulus it with the hash array length, right, almost good enough, almost good enough. But under some condition, right, example, if there's one string, right, is able to make up the total value as 0 also. Example, right, this hash array length, right, is modulus 7, right. So if say your total hash, right, the calculated total hash is say 7, right, 7, or if like the total is 14, right, 7 modulus with the array length. Remember our array length is 7. So 7 modulus 7 is equal to 0. And 14 modulus 7 is also 0. Okay, this is the problem. This is one more problem. It can happen, okay? When you sum up the hash ID, your modulus with the hash array length, it can happen there's multiple collation. The solution is do a probing, okay? What do probing mean? Example, right, if we got the value of 7 and we got the value of 14, right? Say example, we don't know what is this string, okay? We don't know what is this string. This is just an hypothetical scenario, okay? Hypothetical scenario. So let's say this string is A. I represent this string as A, and I represent this string as B, okay? So initially, right, your array is like 7, okay? Still 7. Then there's some item in here. So initially, the hash ID, right, the hash is 0, okay? The hash IDX total is 0 after you modulus it. So you fill in this one, you fill in this into the array. So you fill this to A. Okay, no problem, you're happy. Then when you do this string, right, what happens? It's 0 also. If it's 0, what can you do? You cannot fill in this array. So there's one solution to this. The first solution is to do a linear probing. What linear probing do is, example, if it's already filled in here, you fill into the next one. So you fill B into here. But then there will be a problem, okay? One more problem. So example, what if we have like 15, let's say 15. We get a hash ID X of 15, okay? Let's call this as C, okay? C. So if you have C, right, 15 modulus 7 result is 1, okay? So if you want to put in index 1, what happens? We need to do a probing again. When we do a probing, let's write this as C, okay? C. So what happens when we need to do a probing? We need to move to one more position, C, okay? Then what if you meet another value? Another value also result in 1, okay? You want an example? Sure, I'll give you an example. Let's say 22 modulus 7. 22 modulus 7, right, is still 1, okay? Let's call this as D, okay? Let's say this string as D, okay? This string as D. So let's call this string as D. So this is the problem. When we want to insert a new value, right, if it's occupied already, then we need to keep probing, okay? D. So what happens if we calculate 21? Let's say we have another string. We calculate 21. This time we calculated 21. 21, okay? 21 modulus 7. Another string, okay? Another string. So let's call this as E, okay? Let's call this as E. We don't know the string, this is just a representation. So what we can do is, the index position is at 0, okay? 0 is already filled up, so we need to move to the next. We need to move to the next. We need to move to the next. We need to move to the next empty space. Then only we can fill in E. As you can see, right, linear probing is inefficient. And for this, right, we can call this as cluster. We can call this as cluster, okay? The problem is in here. When there's a cluster, right, you need to insert, when you want to insert the string, it becomes very long. Very long, okay? It's become very long. So what can we do to eliminate this problem? If you want to eliminate this problem, right, we can do double hashing. Double hashing is another method. Okay, I hope up to now, right, you are clear with the concept. So what double hashing do is, we are going to insert, like example, if there's a duplicated in here, right, we insert it to the further position. Don't worry, I will provide you a code sample so you can see the item. Okay, so right now, right, let me erase this. Okay, let's draw the table again. The length is 7. This is the length, okay? The length is 7. Length is 7, okay? 7 is the length. So example, right, what we can do is the algorithm of stepHash. So you can call this as hash 1. Hash 1 is represented by this one. And hash 2 will be represented by this one, okay? So I'm going to write it down. This one is called as hash 1, okay? Hash 1 is called as hash 2, okay? So under the scenario, right, when you use a hash 1, right, we use a hash 1. So let's say this hash 1, right, we call this we represent the string, right? We don't know what is the string, okay? We don't know what is the string. Let's call this represent by A, okay? So if this string A, right, the result of this hash IDX is 7, okay? 7. And then we modulus it by our hash array length. We will modulus it by our hash array length. So it's going to be modulus 7 is equal to 0. Okay, no problem for the first one. So we're going to fill in A in here. So we are happy. So then we perform another hash algorithm. So let's say this is 14. Okay, 14. So what happens if we have a string of call as B? B, right? This string, right? Our hash ID result is 14. When 14 modulus 7, right? The answer is 0. Okay, the answer is 0 too. So what we can do to this B? We cannot insert to A. So what we can do is we're going to put it into the hash2, okay, step hash. So this step hash, right, is going to use the previous prime number, okay? The prime number should be lesser than the table length. So what is the previous prime number come before 7? The answer is 5. So you need to write your prime number function. There are a few prime number algorithm out there. But for me, right, I have a prime number of like generate the next prime number. So user enter 4, right? Then it will give me 5. So this 5, right? I'm not going to put it as the table side. So I reserve it to use in here. I reserve it to be my next step. So I call the function again. What is the next step of next prime. What is the next prime of 5? So when I call next prime of 5, right? Then you generate 7. When it's 7, right? Only then I set it to be my array side. So what I just said is I reserve one prime number first in my private class field. And then, right, the next prime number only I set it as my array. Okay, my array side. So let's get back to here. So this step hash is going to work like this. So let's say our next step is 5, right? Our next step is 5. Next step is 5. Do you know how do we get next step? I already said, right? It's the one previous prime number of the array length going to be 5. So let's say 5. So the algorithm is like this. 5 minus key modulus next step. What do key modulus next step possible result in? Let me show you. If you want to use a key modulus next step, right? Key modulus 5, right? So the possible result is only between 0 to 4. Okay, 0 to 4. So what happens when you use 5 minus 0? When you use 5 minus 0, right? So it's the minimum value. What is the minimum and maximum result of this value? The maximum result of this value, right? Maximum result of this entire thing is actually 5. And the minimum, right? Minimum, what is the minimum? You use 5 minus 4. 5 minus 4 is 1. Okay? 5 minus 4 is 1. So the possible index, right? The possible, I shouldn't call index. Let's call this as step. The possible step generated by this function is between 1 to 5. It will never be 0. It will never be 0, okay? Because you know why? If it's 0, right, meaning there's no change in the index, okay? If it's 0, no change in the index, no point, okay? So this is what this algorithm do. So if first step, okay, first step, let's say 5 minus key. What is our key? Our key is 14. Let's say 14 modulus 5. What is 14 modulus 5? 14 modulus 5 is actually 4. So you're going to use 4 add with 0, okay? 0 add with 4, okay? 0 add with 4. This I, right, should be starting from 1, okay? Starting from 1 and repeat until, it should be repeated until, let me think, I should be 0 plus 4, right? 0 plus 4 is equal to 4. 0 plus 4 is equal to 4. And then 4 modulus with table side. What is our table side? 0 plus 4 modulus with 7. Don't get confused, okay? Don't get confused. This one is string, okay? This one is string. This one is integer, okay? So this one is actually string. This one is string. This one is integer, okay? So the 4 modulus by 7. So the result is 4. So you're going to fill in the position 4. So this is B. This is B. Okay. As I said just now, H1, right, is from this part. Okay. This is called as H1. You can write this as H1. Okay. This is H1. And this one is H2. Okay. H2. Later I'm going to explain what is I. When this occupies space, right, then you're going to increment the I. So H1 is from this part. H2, right? The H2 key, right? This integer, right, is from the HIDX, okay? HIDX. So don't get confused. It's actually HIX, okay? HIDX. This is actually HIDX, okay? This is actually HIDX. So how do we get the max step? If you want to get the max step, right, you use the prime number before the array length, okay? Get the prime number before the array length. Prime number is a magical number. This is also a prime number. You need to make your array size as prime number, and also you need to put your max step as prime number also. This prime number, right, can be one prime number before this array length, okay? User call me set array size as 4, okay? Set array size as 4. So I reserve one space. One prime number is for max step, and then another next prime number, which is 7, right? This 7, I would set it as my array length, okay? I set it as my array length. So let's say, so unfortunately, when we put a string, right, let's say this string, right, is something, right, the hash idx, okay, this column is hash idx modulus by our hash array length, okay, length. So let's say, so unfortunately, we get 7, modulus with 7. The answer is 0. So we fill in A, okay, this unfortunate condition. In the next one, right, let's say we call this hypothetical string as B. This B, right, really unfortunate. We get the hash idx is 7 also. So 7 modulus 7 is also 0. So what we do is, we pass this 7 into our hash2. We pass it to our hash2, okay? So it's going to be look something like this. So it's going to be our next step. What is our next? Previous prime number is 5, okay? So it's going to be 5. So our next step is 5. And then our next step is 5. So the formula is 5 minus with our hash idx, which is 7 modulus 5. So what is this value? 7 modulus 5 is actually 2. Okay, 2. Then 5 minus 2 is actually 3. Okay, 3. So when we get 3, right, we're going to pass into here. Okay. So what is our first hash key? Our first hash key is actually 0. Okay, 0. So and remember, because we are returning the whole thing. Okay, we are returning the whole thing. So the hash ID, the hash1, right, is 0. 0 add with, what is our hash2 value? Hash2 value is 3. So it's going to be like this. 0 plus 3 modulus with the table size. The table size, right, is fixed. Table size is always 7. So we get the index position is at 3. Okay. So we fill in B in here. B is in here. So what do you notice in here? What you notice is initially our index is 0, right? If we counted 3 in here, right, it's essentially increasing by 1, 2, 3, increasing by 3. So let's say we met another string. The hash idx is also 7. Okay, 7. We also met 7. 7 modulus 7 is also 0. What we can do is we pass into this step hash again. In the first round step hash, right? What is the result? The result is 3. But 3 is occupied. Okay. So initially, right, our I is always start from 1. Okay. Our I is always start from 1. So this one is actually 1 multiplied 3. So we are going to increment the I. So 0 plus with 2 multiplied with 3 and modulus with 7. Okay, modulus with 7. Later you will see why this modulus is important. So the answer is 6. Okay, 6. So let's look at this position. So if this position is not filled, right, it's empty, available. So we put C in here. So what do you notice in here? Can you see something? When its position is B, right, in our step hash, we get 3. So starting from this position, right, 1, 2, 3. 3 is our estimated position. Similar to this. Later, right, let's say we have a D. Okay, we have a D. So this D, right, this D is also counted. Hash idx is 7. 7 modulus 7. So what is the estimated D? Our estimated D position is, but this is the end of the array. What we can do is, starting from the first position again. So it's going to be 1, because here, right, we are stopping at C. So in here, 1, 2, 3. So our D position will be in here. Okay, our D position will be in here. So let's prove using this formula. If you want to prove using this formula, right, it's going to be 0 plus 3 multiplied with 3. Remember this 3, right? This 3 is from our hash ID, our hash2. Using our hash2, this 3 is increment. It's increment when this position is filled. When you loop, right? When you loop 3, this position is filled, right? It's not empty. It's not null. Then you are going to increment the I, become 3. So the answer will be 9 modulus with 7. What is 9 modulus with 7? 9 modulus with 7, the answer is 2. Wow! Can you see how amazing is this algorithm? When you exit the array, right, it automatically help you to reset the index position. So that is why this modulus table size is so important. Let's insert another part. Same scenario, okay? Same scenario. We got a string, right? We don't know what is this string. But when we counter the hash idx, right? When we counter the hash idx, we get is 7. Okay, we get 7. 7 modulus 7 is, actually, what is the 7 modulus 7? 7 modulus 7 is 0. Okay, so we are going to pass in again, pass to this hash idx. This hash idx, right, we pass in here. So 5 minus 7 hash idx, right? Hash idx modulus 5 is answer is 3. So we're going to come back to this, okay? So it's going to be 0 from hash1, okay? The result from hash1. 0 add with, because in the third one, right? When we switch to this position, right? It's occupied. Because it's occupied, we are going to put in 4 multiplied with 3 modulus 7. So what is the answer? The answer is 4th modulus 7 is 5. 4th modulus 7 is 5. So in 5th position. So this one is actually E. Okay, E. Let's say F again. Let's say F. F is the same scenario, okay? 7 modulus 7 is equal to 0. So 0 plus with 5, because it's occupied, right? 5, and then we modulus 7. So the answer is 1, okay? So this one is F, okay? This one is F. And the last one, okay? We are moving to the last one, G. Same scenario, okay? Same scenario. This string, right? This string is also the same, 7 modulus 7. So we are going to be 0 plus with 6 modulus 3 modulus 7. So the answer is 4, okay? 4. So neat, right? This algorithm. So the answer is G will be filled in here. So what do you notice in here? The I, right? What is the maximum I possibility? The maximum I possibility is actually array length minus 1, okay? Array length minus 1. The maximum I, right? The maximum I, the possibility of I is actually array length minus 1. Okay, array length minus 1. So example, right? Let's say we want to retrieve this string. Okay, we retrieve this C, okay? C is a simple example. So when we want to retrieve C, right? We counted the hash. We count the hash. So we count the hash. We get 7. So we go to the first table. We go to first table lookup. So if the first table, what do we see? The first table, right? 7 modulus. We are counting C, we are counting C. Let me draw it out. Okay, now we are going to search, okay? We are going to search. We search this string, okay? This string is C, okay? This string is C. The representation of C, okay? The representation of C. We want to search C. So we want to search C, right? We count this hash first. We count using hash 1 first. So we get the result. The result is actually 0. We get the result is 0. So immediately we look up this table. 0, okay? We look up this table. Is this C? Is this string C? No. If it's not, right? Remember, because you have done a double hashing, right? You're going to, because you have propped it before. Because you have propped it before, you need to check from I is equal to 1 until 6. You start from I is equal to 1. Then you start from I is equal to 1. You calculate the hash IDX, then you get the position. What is the position? Position is 3. Then you move to the 3. You move to 3 position. Is this C? Is this C? No, right? You continue to prop, then you go to the next position, 2, okay? Increment I become 2. So when increment I become 2, right? So what is this new position? 6. Then you go to 6. Is it C? Oh yes! We found it! C! Then you get C, you extract out the key and you have the data, okay? So this is the amazing part of hash table. With that, I hope you learned something. I hope this hash table will be useful to you. And this is actually another algorithm how to look for the table if there's probing, and this is just my own method to do probing. So my own method to do probing is, if it's not found, right, you're going to look from I is equal to 1 until I is equal to 6 to look for possible probing. Okay, with that, I end my tutorial in here. Bye bye.